Hi, I'm Alex, and I'm going to tell you about this particular section, Net Present Value, or NPV. If you've already done the section on discounted cash flows, you'll find this easy, because net present value is simply the sum of the discounted cash flows for a capital project. And as we've seen, the discounted cash flows are calculated as the cash flow at any given time t divided by 1 plus the discount rate as a decimal to the power of the period t. So if r, the discount rate, was say 10%, that value would be 0.1, and t will typically be in periods of years, so it'll be year 1, year 2, and so on. So let's just look at a couple of examples. So here we have a simple project. Year 0 is when you have the capital outlay for the project, and then years 1 through 4 are going to be the returns for the cash flows for each of those years. So we start in this particular project with a cash outflow in the first period of 150, and it's minus because it's a cash outflow, and then we will have cash inflows in year 1 of 50, in year 2 of 75, in year 3 of 100, and in year 4, 75. Now the discount rate we're going to apply is 15%, so that would be 0.15 in the formula. And just for completeness, I've included the internal rate of return, which is 32%. And since our required discount rate is 15% and is lower than the IRR, then we can be certain that the net present value should be positive. This line here shows the discounted cash flows, and as we can see in year 0, when we do an immediate cash outflow, there is no discounting, so it's the same value. But thereafter, all the values are now smaller than their undiscounted values. So in year 1, the value is now 43.48, year 2, 56.71, and so on. And if we sum all the cash flows from year 0 through to year 4, we find that the net present value is a positive 58.82. Now we should be able to predict that if we raise the required discount rate from 15% to something higher than the internal rate of return, that the net present value should be negative. And I've done that calculation here using the same project cash flows, starting at the cash outflow of minus 150. And when we discount those now at 40%, which is higher than the internal rate of return of 32%, this line here gives us the new cash flows that when we sum up gives us negative 20.05. Now in corporate finance, the general rule is that the larger the net present value, the more attractive a project is. So in this particular case, we have 3 projects, A, B, and C, with net present values of 1,000, 10,000, and 100,000, and internal rates of return of 15%, 10%, and 2%. Now, using the rule that the largest net present value is the most desirable project, you would choose project C, even though its internal rate of return is apparently quite low. In the real world, the assumptions have to be adjusted a little bit because capital financing isn't infinite, although the period during the 1980s with junk bond financing made it almost appear to be that way. But in practice, you cannot borrow an infinite amount of money for your project, and so there will be a restraint on the largest amount of cash that you can raise to get your project started. In which case, you would then choose the net present value that is consistent with the amount of cash outlay that you can finance for your project. In corporate finance, when you do capital budgeting, net present value is the criterion for which you judge a project's attractiveness. And the larger that value is, the more attractive that project should be, and that should be the one that you should choose, subject to any other restraints in terms of capital outlays.